Another layer that will make our shot look much more realistic and detailed is a broken glass edge layer attached to the window frames. And we're going to use a technique just like we did with the rebar. So if we take a closer look at some of these shattered windows, you can see that's a perfectly clean hole that it's leaving behind, and it'll look much nicer if we have some bits of glass that are stuck to those frames afterwards. Now I'm going to set that up in a different section of our scene, but we're going to want to object merge our windows into that other section from here. So let's add a null after we have that active frame applied to our window geometry. I'll just call that null windows, and then we can jump out of here and make a new section for those glass edges. Now we can dive into our new section and object merge in those windows, and just like we did before, we're going to want to blast away all the windows that are never going to shatter. So I'll go back to our setup for the shattering, and I'll just grab this blast node where we're deleting everything with an active frame greater than 1150, and we'll paste it in here to isolate the windows that are shattering. Now we're going to fracture each of these in a loop, but to test out this loop, I don't want to run on all of these windows. I'm just going to select a subset of them. So let's just hand select one of these rows of windows, and we'll hit delete and flip that blast to delete non-selected. And each of these window panes is a packed object, so we can just use a for each primitive loop to loop over each of those windows and fracture it. So I'll connect that loop up to that blast, and we'll display the first input there. And it looks like that's giving us one of these really skinny windows, and I want to test this out on one of the bigger ones. So I'll set this to single pass and change that value until we get one of these larger windows, and it looks like that one will work. Now to generate some procedural cutters for these glass panes, I'm going to start by just isolating this front face of that window. And to select that outside face, we'll have to first unpack our geometry, and then grab our selection tool and select that and hit delete. And we'll flip that to delete non-selected and display that. So we just have this outer face isolated. Now let's make a little bit of room for our cutter setup, and we'll start by extruding this single face. So drop in a poly extrude, and for this we're only going to use the front face. So you can turn off output side. We'll set that distance to 0.15, and then turn on this transform extruded front option to scale that down a little bit. In this case, I'll scale it down to around 0.86, looks pretty good. And now let's template display our glass pane, and we're going to run another extrusion on this face that we've isolated here. So drop in another poly extrude, and we're going to copy the parameter on the first extrude. We'll copy that distance parameter, and we'll paste the relative reference into our new poly extrude. And the reason we're doing that is because we want to extrude this back through the glass pane. So we're going to set a multiplier on this new poly extrude. We'll set it to -2 times that channel reference that we copied in there. And if you turn off this output front option, that'll just leave us with the side faces that give us this nice ring around the edges of our glass pane. Now to use this as a cutter, we're going to need some more resolution, so I'll add a divide sop, and we can turn off convex polygons, turn on Bricker polygons, and I'll copy that first size parameter and paste the relative reference into Y and Z, and we'll try a size of 0.03. And we don't want to go too terribly high res on this because we'll be fracturing lots of windows and they will be fairly far away. So if you go really high res, then that will be unnecessarily heavy and will be some wasted resolution and wasted system resources. Now let's add some mountain sop detail to this. I'll set that element size to 0.4 and then turn down the height a little bit as well. Looks like around 0.47 works, and I want this to be partially inside and partially outside our glass pane. These partially inside and outside shapes will help to add some interest to the edge detailing that we'll be isolating here. Now, in addition to these edge cutters, we're going to also add some more cutters with our cutter geometry HDA. So let's connect our unpacked geometry to that and display it. And since these default settings are pretty extreme, I keep meaning to turn down the defaults on this. This would be a bit more intuitive if the default amplitudes for both the large and small noise were set to 0, because that will make sure that we always see some cutters from the very beginning. When we have a really massive noise at the very onset of this tool, then sometimes these cutters get pushed too far out of the geometry right away. Now I'll turn on this trim outside object option, and I'll turn the expansion up to 30 to give ourselves some extra buffer around that glass pane. And for the noise settings, it looks like a large noise size and amplitude of 1 work pretty well for this. And for the small noise size, I'll go with 0.2 and 2 for both the size and amplitude on that. Now let's merge these cutters with those edge cutters that we already created, and we'll run our Boolean fracture on this. So we can drop in our shatter HDA and connect our unpacked geometry to that, and our cutters and the second input. And now after this is shattered, we can pack this up based on those name attributes. So drop in the pack, turn on the name option, and then we're going to delete out all the pieces that aren't around the edge. Now to select those central pieces, we'll go back to this ring that we designed around the edge of that glass pane, and I'll add a polyfill to cap that geometry. We'll connect our mountain to that, and then we'll turn this into a VDB to select the pieces. So drop in a VDB from polygons. Since we're working at a pretty small scale, you'll probably have to go a bit smaller with the voxel size on this. I'll try 0.03, and then we can group all of our packed pieces with this VDB. I'll drop in a group SOP. I'll set the group name to center and connect the pack to the first input and our VDB to the second. And on that group, we can turn off the enable for the base group. We'll set this to points, turn on keep in bounding regions, and we'll use our bounding volume option. And with that center section selected, we can now drop in a blast SOP and select that center group. And then finally wire that blast into our for each end. If you want to, you could refine the central selection a little bit. You can use a reshape on that VDB to expand or contract that before that center selection. So if you just drop in your reshape, I'll set this to erode so it allows a little bit more of our edges to come through. And then you can tweak this offset. I'll just try a little offset of 0.2. Even that very slight offset is making a significant difference in how much of that edge is preserved. Now if we turn off that single pass option on the for each end, we can run that fracture on this entire row of windows, and it's good to verify that this procedural setup works regardless of the orientation of the window, and it looks like our fractures are all good. And now that we have verified that this is working correctly, we can go to that blast just before this fracture loop and remove this blast that's isolating this one row of windows and allow this to run on all of our windows. And this took a little while to run on all of the windows since there are quite a few here. We have over 600 windows, and since that took a little bit for this to compute, let's go ahead and cache that out. I'm calling this cache glassedges.bo1.bgeo. This is just a single frame cache, so save current frame, turn on load from disk, and then we'll save that.